All right, what we're going to look at today is product and quotient rule. And today we're only going to get the product rule. I don't even think we're going to get the quotient rule. We will get to quotient rule tomorrow. So we reviewed what we did last week, taking derivatives, bringing down the exponent, subtracting one, which was really the power rule. And the one key to remember with the power rule was it didn't matter if it was like x to the fourth or x to the 1/2 or x to the -3, still worked out to get to those. Okay. Now, one of the problems is what happens if we have something like this. Okay. We can't do the same thing as we did here. So what we want is we're going to come up with a rule to help us in this situation. That will be a quotient rule. Today we want to look at a product rule. So to kind of get us going for it, let's consider this function. X squared plus 3, 3x minus 1. Now, to kind of show you where we're going here, I'm going to FOIL this out. So if I FOIL this out, I will get 3x cubed minus x squared plus 9x minus 3. Now, if it then asks us to find what is our derivative, dy dx would be 9x squared minus 2x plus 9. Okay. All good so far, just like we expect. Now, if you think back to when we were doing these, if you were going to try to take the derivative of this, all you did is you took the derivative of the first and then just added it to the derivative of the second, and you just did each one, right? So if we don't have addition, but we now have a multiplication, what would happen if we just took the derivative of each piece? The derivative of the first piece would just be 2x. The derivative of the second piece would just be 3, which would give us 6x. So you can see we can't just take the derivative of each part, right? There's something else going on if we're going to get this as what the right answer is. Because however we do it, we should get the same thing. And so because of that, we are going to look at the product rule. Okay? So let's look at the product rule here. So there's two ways of writing it. First is the derivative d dx of uv. They use a lot of u's and v's in the formulas in calculus. Or we could think of it as f and g if we think about our other notation. Okay? So notice what we have. If we want to find the derivative of f times g, it is f prime, which is the derivative of f, times g plus f times the derivative of g. Now, product rule is one where it's really, really important for us to remember this formula. Now, instead of remembering it like these written, we're going to remember it in words. So whenever we do product rule, this is the part you want to remember. So what this means that we're going to remember is this. The product rule says the derivative of the first times the second plus the first times the derivative of the second. So I'll let you write that down. So in our head, whenever we're doing product rule, whenever we have one thing times another thing we're taking a derivative, in our brains we want to think of derivative of the first times the second plus the first times derivative of the second. So let's look at coming back over here. So let's look at we have our derivative that we're finding is y, which is x squared plus 3, 3x minus 1. So by our product rule. It is the derivative of the first. So this is our first. This is our second. So derivative of the first, which is 2x, times the second. So you take the derivative of the first one, and the second one just stays exactly the same. Plus the first times the derivative of the second, which is 3. Let me get to there. Now, if I was to multiply that out, I get 6x squared minus 2x plus 3x squared plus 9. And you can see if I combined that, we get to that up there. So that is our product rule. Derivative of the first times the second plus the first times derivative of the second. So let's just do some more. Here. X squared times the quantity 4x to the negative 1 plus 3x squared. Now, on both of the ones we looked at, technically here, you could distribute that through and not use the product rule. Just like here, we could FOIL this and not use the product rule. But as we look at some of these as we get going, when you have something like e to the x, or you get something with a trig function or something, right? You can't do that. So we have to understand. So let's walk through our product rule. Product rule says what? Derivative of the first times the second plus the first times the derivative of the second. And you can see all that we did last week. One of the things about derivatives you'll find is like what we worked on last week, whether you thought it was easy, you thought it was hard, you're going to keep using that over and over and over again, that eventually, even if it was not super easy, it will become super easy because we're going to use it so much. So now, at this point, we're not even going to simplify that. We're just going to leave it. Right? We're not going to worry about simplifying it. We want to be able to see where everything comes from, so we'll just leave it there. Okay. All right, try that one. E to the x times 4x cubed plus 2x. See if you can do the product rule. Derivative of the first times the second plus the first times derivative of the second.
Don't you have to leave e to the x the same?
What do you mean?
No,
What do you mean by that?
Because, I don't know, I forget what it was last week. Or do I just do x times e? Just leave it e to the x for the derivative.
So, I kind of understand what you're saying, but I'm trying to get you to say it maybe in the right way. So, because I know what you're thinking, but so, like if we wanted to write this out, let me write this out like in more detail than you would ever do, but let's do it because this is the first one. It is the derivative of the first times the second plus the first times the derivative of the second. So that's our product. Now what you're thinking about is, what is the derivative of e to the x? You said it a second ago. The derivative of e to the x is just e to the x. It's the exact same thing. The derivative of e to the x is just e to the x plus e to the x times 12x squared. Try the last one there. You both got it. Derivative of the first times the second plus the first times derivative of the second. Okay. All right. Try the other one. Let's say we have the x times e to the x. Now, before we get to the question over here, let's find the first derivative. What would be the first derivative of x e to the x? Try writing that down. Product rule. It's x times e to the x. Derivative of the first, what's the derivative of x? 1 plus the first times derivative of the second. Now, what would the second derivative be? What is the derivative of e to the x? E to the x. And then what is the derivative of x e to the x? Just that, isn't it? That's what we started with. So then we'd get e to the x plus x e to the x. So what would our third derivative be? E to the x plus e to the x plus e to the x plus x e to the x. And one of the things with derivatives, when we were talking about like polynomials, and you take the derivative, right? You just keep taking it, and eventually your x goes to 1, your x goes to 0, you just get a number, and then if you take derivatives over and over again, eventually it just goes to 0. When you start having things like e to the x, it actually just kind of keeps getting more complicated, doesn't it? That's kind of the opposite of where we started today when you have something like this. What's going on here? When you have something like that. If we would just take the derivative of this over and over and over again, it would eventually just go to 0. You just keep subtracting exponents and it eventually goes to 0. But when you have e to the x and you have something like that, this is just going to get more complicated and more complicated. So let's see. Do we understand the pattern now? What do you think the fourth derivative would be?
E to the x plus 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 x e to the x.
Now, if you notice, the fourth derivative there's how many of them?
4.
4. So that is 4 e to the x. For the third derivative, there is 3 e to the x. For the second derivative, there is 2 e to the x. So what would our formula be for the nth derivative? How many e to the x's would we have in the front? N. So we get n times e to the x plus x. E to the x. Okay. All right. we're just gonna try some more of these, just do some practice before we move on. So I'm gonna pause this and then we'll come back and all right, so let's look at our answers here. Now we'll go over a couple things. So here is the first one. Derivative of the first times the second plus the first times derivative of the second. So here is our first. Here's the first. So here's the derivative of the first times the second plus the first times derivative of the second. Our first thing here is we needed to write 5 sine of x, and we had to change the second to x to the negative 4. So it's derivative of the first times the second plus the first times derivative of the second. And the one thing to remember, we haven't proved it yet, but the idea is the derivative of sine is just cosine, right? Later, as we go through this week, we're going to prove the derivative of e to the x is just e to the x. And we will prove the derivative of sine is cosine and what the derivative of cosine is also. We haven't proved those yet. We kind of talked about them based on the shapes and the graphs last week, but we will prove those as we go. 3, we kind of did that one before, right? You had to kind of write it to the negative 4. Okay. Number 4, our first was e plus 2x. So we have the derivative of the first times the second plus the first times derivative of the second. So far, so good?
Oh yeah, I did have that.
Okay.
Yeah.
All right. So let's go to the back. So first, we have the first derivative. Which is the derivative of the first, 3x squared, times e to the x, plus the first times the derivative of e to the x is just e to the x. Now, to find the second derivative, one of the things that's useful to do sometimes when you want to find the second derivative is it's sometimes easier to simplify that. So I factored out e to the x and just made it x cubed plus 3x squared plus 1. Otherwise, I would have to do product rule of the first and product rule with the second part, right? You'd have 2 product rules. By factoring it out and rewriting, I only have 1 product rule to get to there. If you did product rule up here, if I did it here, I would have e to the x 3x squared plus e to the x plus 6x plus 3x squared e to the x plus x cubed plus 1 e to the x. See how you would have 4 parts there?
Yeah.
Because you would have the first part here, you would have to do product rule. And then the second part here, you would have to do product rule on. So you'd end up with 4 parts. So if you can simplify it like this, it then makes the second derivative a little bit easier. But you got to simplify it and you got to do some other math. So I'm not sure. All right, the last one. If f of 2 is 10 and f prime of x is x squared f of x, find f double prime of 2. So, first off, let me write something up here before I go down. If f of 2 is 10, what is f prime of 2?
0.
Why?
Because it's a constant.
Well, f of 2 is equal to 10. So that means wherever the graph of f looks like, we don't know what f looks like. But when x is 2, the value is 10. Now, we know what is f prime equal to. Squared f of x. So f prime of 2 would be 2 squared times f of 2. Well, what is f of 2? 10 times 4, so that would be 40. Does that make sense? Now, if I want to find the second derivative, if I know this is the first derivative, how would I find the second derivative? I'd take the derivative of the derivative. So the second derivative would be the derivative of the first, x squared, which is just 2x, times the derivative of the first times the second, plus the first times derivative of the second. Just pause there for a second and see if that makes sense. The first is x squared, the second is f of x. So derivative of the first, 2x, times the second, f of x, plus the first, x squared, times the second, derivative of the second, f prime. Now, we want to find f prime of 2. So now I just substitute 2 in everything. But we know, what is f of 2? 10. And then up here, what was f prime of 2? 40. So now you can just sub all of that in to get 200. That's not like super easy. That's not an easy problem, especially the first time you see it. Just helping us to understand all that we're doing with. All right. So today we were just looking at the product rule. And really we have formulas for the product rule, but understanding what it means is really how you want to do it. Derivative of the first times the second plus the first times derivative of the second. You want to just tell yourself that in your head anytime you have two functions that you're multiplying together to look at the derivative. Okay. Tomorrow we want to look at what happens if you have a fraction. How do we find the derivative of a fraction? And it's not a fraction rule. It's going to be called the quotient rule. And we will look at that tomorrow. What is our rule to find the derivative of a fraction? Okay. Homework is Delta Math. And I'll make sure that that's up.